Hello, welcome to our Kaleidoscope Live. We hope you're having a good evening. We are the Kaleidoscope team from the British Journal of Psychiatry. So every month we write an article in the British Journal where we pull together the best science ever. And what we do with this is we talk through a couple of the papers within it. And we're really pushing IT tonight. We're going to have Dan and Dawn in a single room. Look at that. We're really excited to be doing that. We've got two papers we're going to talk through today. We're going to talk through one on AI and we're going to talk through one on poo. We're going to start with poo because we've been having that sort of afternoon trying to get everyone together to be here on time. It's been a rush for us. So Dawn, you're going to start talking, and specifically baby poo. So people sometimes want to know the papers. They are in the links. And by the way, Kieran put it in the chat. Do add in questions or comments. We'll try and get to them during the podcast if we can. But the actual title of the paper, it's not poo, it is Sex-Specific Relationships of the Infant Microbiome and Early Childhood Behavioral Outcomes. So it's by Laue et al. In Pediatric Research. Over to you, Dawn.
Thank you very much. So this is a paper out of the Gesell School of Medicine at Dartmouth, and they've taken a really interesting approach. So they're interested in the microbiome, of course, the sort of bacteria and fungi that live within our gastrointestinal tract and have in recent years been linked with a whole host of things, having an impact on kind of our behavior and mental health. And they were really interested in looking in very early life. So what they did was they used some participants from actually a birth cohort study. So they recruited the moms when they were pregnant. A couple of things, they had to have well water, kind of very specific, isolated water sources, that kind of thing. And once the babies were born, they had those mothers, in addition to filling out some behavioral surveys and other information about the development of the child, they had them collect poo samples at 6 weeks, 1 year, and 2 years. And then at 3 years of age, they filled out something called a BASC. It's a behavioral scale for children that looks at indicators of potential future kind of internalizing, like anxiety and depression, or externalizing social difficulties, that kind of thing, to see what, if any, relationship there was between the microbiome in those early stages and future behavior output. Now, the reason they were interested in this is because there have been links to the sort of flora in your gut and ultimately these types of disorders. But by the time you are doing that study, you've got adults who effectively already have the disorder, and there's kind of no way of really even attempting to gauge any kind of directionality in that relationship. So by taking a look at the human organism during kind of a critical window of time when both the microbiome itself and the brain are developing, at an exponential pace, you get a better sense of, chicken or egg, which came first. Overall, what they found was, they would argue, and they make a big claim of time and sex-specific influence of the microbiome on this future behavior scale. They did find that, of course, for all infants, the microbiome flourished in those early days, and it appears to be somewhat protective, but only for boys. So the more diverse microbiome they had at 6 months, at 6 weeks, the lower indicator scores they had ultimately for the internalizing behaviors, or the anxiety and depression related stuff. For girls, actually, a particular species, if it was high during that period of time, seemed to correlate with some negative outcomes around anxiety. And you see a separate protective effect of a streptococcal strain at 1 year. So you get these kind of bits and pieces that indicate that something is going on. But actually what they pull from the paper as being one of the most interesting aspects of their results is that they were sex specific. And this is during a period of life when, the gonads aren't releasing any kind of sex specific hormones. And so that's really interesting. That appears to be something much more fundamental. And we know that in some of these disorders, there are real significant sex differences. And so perhaps this is a small piece of the puzzle. They sell it, and as all papers do towards the end, as really trying to elucidate the processes early in life to create opportunity for potential intervention points that perhaps actually, if you knew the makeup of your child's microbiome, you could, give them a little extra yogurt or, a little kimchi or whatever at certain age points, and maybe actually positively impact the outcome of their lives. And of course, all parents want the very best for their kids. And so that's really, really appealing. Obviously, the data aren't there yet. And it kind of had me looking around to see, what do we know about this stuff? I can recall very clearly somewhere in the last 5 to 10 years when the gut-brain axis kind of really blew up in science and people got really interested in this connection. And it is absolutely fascinating. And I think it's got an appeal that is somewhat intuitive. It plays to, I think, in the general population, as well as scientists, it plays to our understanding that we understand that if someone has low blood sugar, that in fact they could be really crabby. We kind of get that, that could be a thing, that could be a connection point. And I was looking around and I think that the appeal is also that is a way of imagining having a leverage point for our mental health that isn't medicine. I think a lot of people would rather avoid that. So I was looking around and I stumbled on something called nutritional psychiatry, which seems to have sprung up in about 2017. And I'm going to go a wild west, right? Like very well intended and 100% playing to these parts that are really appealing to us about this idea of manipulating our microbiome, for better overall life and well-being. But in that way is also somewhat unregulated part of the wellness industry. And, I think overall what I took away from it, but I throw it to you as my psychiatrist, it seems to me like if we're going to do a nutritional psychiatry kind of thing, then what we actually really need is a rigorous, comprehensive understanding of the baseline biological makeup of the factors that influence mental health. And then we would need a comprehensive understanding of how nutrition goes in and impacts it. So how can we tell the difference between snake oil and a potential intervention point?
Yeah, I thought Wild West snake oil, and I thought I smelled shit. So I do wonder what Suki done. Are there dangers with this? So I always worry. I put this piece in Kaleidoscope. I take responsibility, but is it just seductive science? It's fun. It's interesting. They put a rude word in the title, or maybe that was us. Do you think there's anything behind it?
I mean, it's clearly the microbiome, how your gut metabolizes food, has an impact on just simplistically just on what goes into the bloodstream. So if your microbiome is such that you can't absorb certain things, then clearly you're going to restrict the number of kind of baseline compounds that go in that might be involved in neurotransmitters, for example. So one of the classic experiments used to induce depression is to do tryptophan depletion. So you actually just deplete the diet in a particular way. That means that less of the substrate for serotonin is absorbed, and therefore there is a chance that you will develop a kind of depressive phenotype. If you have microbiome changes which will influence that, and clearly we know that the microbiome will influence how you metabolize the things that go into your gut, then there is, I think, an intuitive link between what's in the microbiome and what's going on in the brain. And there's certainly, if not persuasive, then there's certainly suggestive data from both amyotrophic lateral sclerosis and Parkinson's disease that it looks like, at least certainly in mouse models, that the biome influences the behavioral phenotypes. So I think the early bits of the correlations and the kind of cross-sectional data suggests that there is going to be a link between the microbiome and brain activity. And if it influences brain activity, then clearly there's more than a chance that it will influence mental health or well-being, if you want to describe it more globally. I think there's a kind of confound, which I think Dawn alluded to very well, that, you know, there is a kind of zeitgeist for improving your health, and part of that may be the kimchi. It may well be it's not an accident that if you go into your kind of local, you know, superstore or grocery shop, that from just being able to buy one kind of very simple looking yogurt 20 years ago, that now there's, you know, almost like an aisle of different, along with different lactobacilli. And I was kind of just interested to see, can you actually tell what the dose loads are in those products? And actually, it's impossible to find out, despite kind of Googling them, despite having a look at the label, despite doing a little bit more kind of intensive search around that. Certainly, they're used clinically in some populations where they're trying to recover people's kind of gut health, where you've killed everything off either with chemotherapy or antibiotics. And there is a kind of graded system that you use a certain density of lactobacilli, whichever strain they're using, so they actually quantify how much is going in. But I think that kind of confound is not going to be easy to remove. The only way is going to be through continuing these kind of correlational studies, maybe doing something a bit braver. And certainly in some gastric disorders, we know that people are using fecal transplant to try and induce healthier gut biome, and with good effects, particularly in kind of antibiotic resistance and so on. So I think there's definitely signal in the midst of the noise. The question really is how clearly you can link that to the kind of the symptoms or functioning that you see in mental illness. And I think one of the things I guess we haven't mentioned is it's really difficult to get things into the brain. Now, we know that from kind of medications, but equally, if you want to examine what's going on with neurotransmitters, we don't have any easily accessible ways of doing that. So if by chance there was a good correlation between the biome and kind of brain activity or neurotransmitter activity, that at least is a place that's much more accessible. And if that's the case, then it should be much easier to do interventional studies to test your theories out.
Some of the specificity of it too. We did a different paper in KALEIDOSCOPE some years ago, and it was a pilot piece of work looking at changing the microbiome. And someone's mentioned in the chat about probiotics and so forth. And the authors of that paper were able to get EEG changes. It's kind of proof of concept, but the lack of specificity. So you could show you could send a signal up to the thing in there, but what it was actually doing and what that might mean seemed quite uncertain. Dan,
I think also, I was just going to say before I forgot, is that if you look at just the sheer range of bacteria that you can examine, plus the fact that the more sophisticated way of looking at that is not to actually culture the actual, bacteria, but actually to have a look at the different kinds of gene expression that are evident in the samples that you're looking at. So actually you've got a very, very specific way of looking at what is available there and the kind of density that it's available in. But how they're going to interact with each other, like everything else, is going to be key. That just measuring them in isolation, not knowing what they do to each other, whether one switches it off, one switches it on, whether one is a substrate for something else or produces a substrate. There's going to be a huge level of complexity that this kind of one-to-one correspondence that we're trying to say there's too much of this bacteria means that they may have fewer ADHD symptoms or such like, or there's a gender effect. I just kind of think that complexity is also going to need to be teased out. It may be that may be easier to do in vitro. You actually can take the bugs and culture them and see what happens. Sorry, Dan, I interrupted you in mid-flow.
No, you didn't. I was exploiting the fact we're on mute, and I was asking you on a question. My question was this: so I don't understand the paper fully, so this might be a moot point. But it struck me that they've identified of all of the, however many flora live in our guts and keep us functioning. I was thinking about this from an evolutionary perspective. If they've identified 2, 3, 4 species and linked it to internalizing symptoms, anxiety and depression, right? And then they took another one of those species was linked to different sets of symptoms and they're arguing it's sex specific. That is remarkably specific, considering we have what, of the order tens of thousands of bacteria living in our gut. So from an evolutionary perspective, it seems to me that if our guts are that sensitive to losing just one species, right, wouldn't we all be running around with ADHD, or wouldn't, do you know what I mean? It seems remarkably specific. And when something seems remarkably specific, when you've got a lot of data but only a few observations, we've got a name for that now. We call them false positives. So the cynic in me, who didn't read the paper very carefully and didn't understand it, I have to add, just wonders, I mean, can we be this specific in mapping from, what is it, the BACS scale? So domain sum scores on the BACS scale, of which I think they use 4 or 5, mapping to individual gut bacteria species seems remarkably specific.
To take that on, so you guys know I'm interested in evolutionary psychiatry, so I'm also interested in ancient poo, and there have been studies done looking at that from populations like Roman populations, going back trying to get samples from earlier humans, and there's such variability, and there's cross-cultural variability too. And there were comments about fermented food, antibiotics for children, and all the different things. It feels so many things could confound that, and you're right, then going to the specificity of it. So it feels that there's a signal. That part I felt viable to me, but there's the extrapolation from that felt fantastical.
So I do think that there's quite a bit of distance between microbiome at 6 weeks of age and ultimate sort of outcomes and trajectories in mental health. I like the idea, I like the potential, but it reminds me so much. I don't know if you guys recall, but the very first time we tried to do K-Live in like a little tiny pilot, I brought you another poo paper. And actually this one that we're talking about today feels actually just ever so much further, less realistic, more vulnerable to noise, as Dan was saying, than the one before. And that one was talking about manipulation of the gut flora as a way to actually kind of ramp up or ramp down the way a body processes a medication that would have an influence on mental health. And that somehow in my mind, if you go microbiome, medication in the middle as like a mitigating factor, and then mental health, I go, yeah, okay. I feel like it's almost like a little bridge to get us to that end point. And even if we had the knowledge or the ability to do that in any kind of reliable way, that would be a revelation, right? If we could increase, the effectiveness of what we're trying to do, even if it's via medication through this route, that's still a great win. So I think there's a ton left to learn, but it really is an interesting space, and again, full of potential. And I always gravitate towards the stuff that brings us hope. But give me a supermarket aisle full of yogurt and let me pick. I think it sounds good.
There's a comment about, are we creating diseases or potentially by altering the microbiome of children, which I guess is an interesting idea. A technical point from the paper, I don't know if you have the answer to it, Dawn. Hazel asked about your point on gonads not secreting specific hormones during that time.
So it's interesting that you say that, because I actually went, what? When I read that as well. I had the same exact reaction. And I'll try to find it. I've got the paper physically here right now. I'll try to find it one more time. And I'll pop it into the chat. But at the very least, I think we can feel confident that they're not, doing any kind of massive activity during this period of time. But I'll find the bit and I'll send it to you.
I'm grateful.
But I did. Oh, sorry.
No, go ahead.
I was just going to say, I did see in the chat, someone was asking about cesarean section versus birth, and that was a covariate. They did a whole bunch of covariates around the mothers and the fathers and circumstances of birth. So that was held in control. I'm just grateful. I thought that, Dawn, you were going to make some cheap jibe on the gender differences about boys being full of shit, but you didn't Never,
drop that low.
Never,
I'm really pleased. And we would not like to, as a podcast, do that. But we're going to move on to our second paper about AI in healthcare. Now, what Dan set himself up with this, because at the start of the paper, Dan, you quoted Einstein. And you said, the Einstein quote was, if you can't explain it simply, you don't understand it well enough. So could you explain AI to us, please? And AI in healthcare.
Well, simple answer is no. Thank you for the reminder of the quote. I'd forgotten that. But the reason I liked it, so this paper was exciting to me because with all the excitement and the zeitgeist around pushing AI into healthcare, and AI is a horribly loose term, a bit like microbiome. And equally, one could argue that the field is somewhat full of feces. So the reason I got excited about this paper is because most often with AI, machine learning, computational methods in general, you pump a bunch of data in and it delivers you an output. And the output is very often interpreted as a clinical decision. Great example being, here's an X-ray of someone's chest. Do they or do they not have pneumonia? And that end to end, so data in, decision out, that kind of modeling is super exciting to industry, it's super exciting to academics, and it's super exciting to clinicians because it could potentially really help. It could make a real difference. The problem is the excitement about this has started to wane a little bit when people realize that the decisions that are output from these things are contained or are erroneous in important ways. And the ways they can be erroneous in a number of ways. One is on average, they can be wrong. The model that you've trained and put all this effort and love into can just give you the wrong answer, in which case it's no better than, for example, tossing a coin to decide if someone has pneumonia. But some of these models obviously get way better performance than that, but no one can work out the route from the inputs through this complex series of calculations or computations to the output. And the problem is no one trusts something that cannot explain what it's doing. Now, the nice thing about clinicians is generally you can probe them. So you can say, you've looked at my results and you've said I've got a pneumonia. Why do you say that? And the clinician can pull out your X-ray and point to the lump or the opacity on your X-ray and say, well, that's why, because there's a collection there and it looks like fluid. And my experience interpreting hundreds of thousands of these images means I think you have a pneumonia, for example. But of course, you correlate it with a lot of other information about the patient. So this idea of explainability became important because of the potential for harm caused by bad decision-making or the model making bad decisions. So this paper in JAMA by Ghassemi et al. Was really exciting because there's been a ton of effort in the last 5 years on transparency and explainability, which I don't think are the same things. A transparent model isn't necessarily one that gives you a good explanation and vice versa. But the idea of this paper was, after all that excitement, this group from Harvard said, actually, sorry, I think they're MIT, not Harvard. I think they're both. Anyhow, the important thing is, Ghassemi et al.'s paper in JAMA says all this excitement and investment in terms of explainability and transparency is for nothing, because ultimately, we don't have a good definition of transparency. We don't have a good definition of explainability. We can never really tease apart these models in a way that makes sense. We tend to, if we are given some transparent explanation for what the model's doing, its behavior, then we tend to favor the one that agrees with us anyway. So if the model is right 70% of the time, and you look at the bits of the X-ray that it looks at, and you're, well, that's pretty much where the pneumonia is, you're assuming that's correct because you're assuming the model's doing what you're doing. Yeah. So their argument is all this effort and excitement about transparent models and explainability in AI is for nothing because we can't get this working. And secondly, they say, why focus on that? Because we'll never get there. Instead, what we should do is just have really robust validation of the models, which is to say the models, you don't just develop a model on a couple of hundred X-rays or a couple of thousand X-rays, publish it, get excited about it, spin off a company, get some investors, make $1 million, sell it to Google and move on. Instead, you're committed to a prospective RCT that evaluates the performance of the model in situ, not in the lab, not on your laptop, not at your desk when you have access to a wealth of analysis tools, but actually with the clinician sat next to it. So their argument is ditch explainability and transparency, go for robust validation and demonstrable proof of benefit from prospective studies of these things in practice, not in silico, not in your lab, not in your bedroom on your laptop, but actually sat next to clinicians. So that excited me. I've rambled on and I've got issues. There's a few issues in the paper that I don't think are quite right. So I think they mistake their example of inherent explainability is a model whereby you can clearly see how the inputs relate to the outputs. And they call that a decision and they give linear regression as an example of that. But I don't agree with that. I don't think that is a decision. That's simply a model of the inputs and the relationships between each other with respect to a continuous output. I don't think that's the same as decision making. And in fact, most AI models bake in decision making into the actual architecture of the model. So I think they've got a few things there that I don't quite agree with, but I think the overall message, I think, is a pretty powerful one. I think it kind of pushes the responsibility away from system architects and engineers to try and make their models look like something a clinician can understand. It pushes it away from that and firmly onto the behavior of these things as medical devices in the same way we treat a pacemaker. If a pacemaker killed 1 in 100 of its beneficiaries, then this would not be considered a safe medical device. In the same way, these systems should be viewed through that lens, I think. So that's my spiel on it. Anyway, I don't know I agree with their definitions. I think there's a difference between transparency and explainability, but I do take their point that actually really hard, robust validation in situ rather than in silico is probably the way forward. What do you guys think?
Can I ask a question, actually? So I'm really interested in this. And in general, hearing you talk, I go, yes, I agree. Dan's very smart. I agree. But that's me not robustly validating my decisions.
You need to explain that.
But actually, what I'm really interested in is, okay, cool, let's do that. That's our new approach. Great. Who pays for that? Where does that burden fall? And therefore, where is that going to fall down? Like, I'm interested in, okay, I like the idea. What is going to be the difficulty translating that into practice?
It's a brilliant question.
Thank you, sir.
Yeah. At the moment, those costs will fall to the developer, I guess, right? If you're developing this thing, you've got to prove that it's reliable in practice. And whoever develops has to pay for and conduct the validation testing.
But are they actually qualified to, right? Because it seems to me like those are two totally separate entities. If you've got like the computer people doing the computer stuff, then you've got the people who run clinical trials. Do they need to merge? Like, actually, do we not need to make a company and then sell it to Google? Like, isn't this actually inherently, like, I'm interested in the finances of it because I think that's where things often fall down.
It's a really good point. I mean, for other devices and other technologies and interventions, we do health technology assessments, right? So the NIHR and NICE pay for that kind of thing.
Okay.
So I guess it's an interesting question, and the government has spun little segments of the NHS off into AI labs and technology innovation or incubators and stuff like this. So it seems that there's a desire to share those costs, I guess. Okay. But yeah, that's very political and strategic. And yeah, I can't have an answer to that.
Yeah, like who wins? Do you know what I mean? Who wins?
I got an email today from NHSX inviting me to one of these. It's an investor conference. It's a really weird hybrid. Inviting, I'm not an investor, but inviting clinicians, managers. I probably fall into that bucket, and IT investors. But it also, again, I withdrew at that point in a sense. Again, I felt snake oil. But there does seem to be a move towards trying to have innovation. I also want to draw attention to Charlotte's comment that Dan is very smart. I want to highlight that because Dan doesn't respond well to praise. So I just I want to tease him. Charlotte's very right that we rely on him, which is why we're in a panic when we thought he wouldn't be here. Suki, any comments on the paper?
I think the paper is really valuable, actually, because I think the people fall into two camps, essentially. You see this really elegant modeling and very high predictive values to say essentially that human beings and clinicians are fundamentally flawed because they can't take all the information that's available, either in terms of an image, a bunch of tests, 100 sets of questionnaires, but that we have machines which can think and use, a factor of 100, 1,000, 1,000,000 times more data. So why would it not be helpful to use all of that data in order to make decisions, particularly with relatively simple things like if you show a picture of the retina, the back of the eye, and you want to say, here, this is when there's been bleeding in those blood vessels. Here's an example, and here's a bunch where there hasn't been any bleeding. So that the machine would then be able to use all of the data that's available and would come up with a result which is as good as an ophthalmologist looking at those scans, for example. So I think there's, without a doubt, that the fact that machines can use much more data than is accessible to humans is, without a doubt, will have some benefits. So at the moment, I guess one of the concerns that's really been raised, I think, by both Dan, who's very smart, and Dawn, who's also very smart, is you're seeing lots and lots of publications. So every week there are publications saying we've used an artificial intelligence algorithm to classify something. So and mental health issues are not devoid from that. And in fact, the next paper we're going to look at, if we have time, kind of looks at Alzheimer's disease or potential Alzheimer's disease. And so there's lots of classification systems using AI. And I think if you're uncritical, you look at those and you think, this is fantastic, right? Like doctors are going to be, we're not going to need them anymore. The job is done. We're going to use, this is going to be another, something like, cars that drive themselves, or, whatever it is that actually was going to remove a layer of ignorance and opinion. And this is a fantastic way of doing that. And actually, I think this paper says that's just not likely to happen in that simplistic sense, because the way, if you want clinicians to use these tools as variables which help them make decisions, they intuitively want to know what mechanism is working. And they describe how you can, and there the paper says, you can't use this very simplistic idea that actually the mechanism is going to be helpful, because when you look at the mechanism that these models use, often it can not really, you can't interpret that. You can, if you're the way the machine is interpreting that is different from the way you're going to interpret. And they give this a couple of kind of superficial examples of, can you recognize, can you train the machine to look at skin lesions or something where you've got, are they cancerous, are they not cancerous? Just with pictures. And then they said, we've got a very high, the system can work, and the system will identify malignant lesions. So this is fantastic, right? Wherever we haven't got doctors, where they're not be available, this thing could work. And then they tried the explanatory model on it, the mechanism. What mechanism is it using to identify this? And actually, the most kind of the hotspot, the most discerning thing was the fact that on the skin lesions, the surgeons had put little marks to say, this is the bit we're going to cut out and where the margins were going to be. So when you looked at the hotspot was actually nothing to do with the actual image of the skin cancer. It was actually a complete artifact. So you were getting very high predictive kind of validity out of it. But actually, if you try to understand where that was coming from, it was coming from a completely erroneous source, unrelated to that. So I think what it does is shine a light, I think, this paper, on an area where we need to have much more thought. So I think it's not generating an answer, but what it's doing is generating very helpful set of questions that when people are reading these papers, and particularly as this volume is only going to increase, right? The number of papers using this methodology is already kind of rising exponentially. It's going to probably go a little bit even straight up in the air rather than. So I think having an awareness of what the limitations are, and also the limitations of us trying to understand these mechanistic things, is really valuable. I found it quite eye-opening myself.
Did you want to take that on, Suki? I mean, we're getting lower on time, but to maybe summarize with that Alzheimer's paper about how it might be extrapolated into practice.
Well, the Alzheimer's paper, the other paper that's there, is essentially a paper that says that we use these very, very large imaging data sets to try and predict brain images of folk who are going to be at higher risk of developing Alzheimer's. And it's predicated on the idea that we know that even before people become ill, they'll have higher loads of various factors, including, the beta amyloid, for example. But you can't really assess beta amyloid in the brain unless you do PET scanning, and that's not widely available. So what they're saying is, there a way that we could just use the traditional structural imaging approaches to try and pick people out who look like they're going to be at higher risk? And they do a bunch of, they use quite a robust methodology, at least to my untrained eye, in terms of using several different samples in terms of where they're testing things and where they're validating things. And their conclusion that they arrive is that they can find an algorithm which will separate out people who have an Alzheimer's like brain picture early on, before they're likely to develop that. And then their confirmatory kind of testing is to show that the people who have this profile have lower cognitive scores than the people who don't have that profile. And then they do exactly what it says you shouldn't do in the paper that we've been discussing, where they look for a kind of, within the model, which aspects of it, what are the kind of hotspots that are contributing to this. And they say these hotspots in particular regions of the brain that we know are implicated in neurodegeneration, the hippocampus, the amygdala, the prefrontal cortex, that these are the regions that when you look at the classification that they're using to show differences between the people who are more likely to develop Alzheimer's, that they show regional changes in these kind of classical regions. So I kind of think it's an interesting, here's a paper that really uses that methodology and makes a case that this is adding something very useful. And you've got another paper which says you need to approach this kind of work relatively cautiously in terms of what you can interpret from that. So you're seeing both ends of the spectrum here.
I think that's a good point to draw this to a close. I think the AI problem should be applied to the poo problem. It's my main takeaway from this. But thanks everyone for joining us. We hope to see you again next month.
Bye.